All right, this is a screencast for Module 5, Lesson 3, and we're going to start interpreting rate of change and slope. Okay, so first of all, it says for a function defined in terms of x and y, the rate of change over a part of the domain of the function is a ratio that compares the change in y to the change in x over that part of the domain. Okay, so rate of change is the change in y divided by the change in x. You guys know this as slope. Rate of change on a graph is shown by slope. That little triangle is shorthand. It's not just my shorthand, it's the way a lot of math and science people write the word change in. So this means your change in y values divided by your change in x values. Okay, so the table shows the year and the cost of sending a 1-ounce letter in cents. So you have your domain is the year after 2000, or the number of years after 2000, and then the range, or the y value, would be your cost in cents. And it's asking you at the bottom to find the rate of change for each time period using the table. So from 2003 to 2004, that is a change of 1 year, but if you noticed from the table, there was no change in cost. So the change in y value was 0, the change in x value is 1, and 0 divided by 1 gave you an increase of 0 cents per year over that time period. So the slope was 0 for that time period. Okay, from 2004 to 2006, you're going to take the second value, 2006 minus 2004, or 6 years after minus 4 years after. So that's a change of 2 for your x values. For your y values, that changed by 2 also. And 2 over 2 is changed by a rate of 1 cent per year for that interval. Then we look at the next interval from 2006 to 2008. 8 minus 6 gives you your change in x values, or your change in time. And then 42 minus 39 gives you the change in y values, or the cost of sending that letter. 42 minus 39, 3 over 2, and that's a 1.5 cent per year increase. And then from 2008 to 2013, that's 13 minus 8 is your change in x values. 46 minus 42 is your change in y values. And that's a rate of about 0.8 cents per year. Okay, if we were to put this on a graph, here's what it would look like. It says to plot the points represented in the table and connect the points with a line segment to make a statistical line graph. Okay, going back to the table, I can take my ordered pairs and plot them on the graph as points, and then connect the points, and you have different line segments. Okay. So from 2003 to 2004, that line segment is horizontal, meaning that has 0 slope. And then from 2004 to 2006, your change was, I think, what, 1 cent per year? Yep. Okay. And then from 2006 to 2008, the change was 1.5 cent per year. And then from 2008 to 2013, again, you're just looking at rise over run, that change was 0.8 cents per year. But you can find the slope for each one of those individual line segments. Okay. All right, continuing on with the same problem. Find the rate of change for each time period using the graph. Okay. You're basically doing the same thing, but graphically. Okay, 1 cent per year, 1.5 cents per year, 0.8 cents per year. Okay, for 2006 minus 2004, 2008 minus 2006, 2013 minus 2008, etc. Okay? Between which 2 years is the rate of change the greatest? And that is between 2006 and 2008, because your rate was 1.5 cents per year. That was the steepest for your slope. Compare the line segment between 2006 and 2008 with the line segment between 2008 and 2013. Which is steeper? Well, 2006 to 2008 is steeper. Remember, we said it was 1.5 cents per year. And so therefore, it represents a greater rate of change. Okay? And you notice that this that we graphed is definitely a function. It would pass the vertical line test, for instance. But the slope of the line does not remain constant for the entire line. So the slope changes. Okay? All right, join me in just a second on page 221. All right, we're now on page 221, where it says determining the slope of a line. The rate of change for a linear function can be calculated using the rise and run of the graph of the function. The rise is the difference in the y values of the 2 points on the line, and the run is the difference in the x values of the 2 points on the line. And the slope of a line is the ratio of rise to run for any 2 points on the line. That shouldn't be brand new to you, because we've kind of already been doing that, but they decided to officially define it and whatnot. So slope is difference in y values over difference in x values. In regular people terms, it's rise over run. So your slope is change in y values over change in x values. And remember, for whatever reason, they have decided in equations to use the letter m to represent slope. So slope is equal to change in y over change in x. Okay, so for example 1a, you're asked to find the slope of each line. So you've got a line that's been graphed, and you have 2 points on the line. What you're going to do is you're going to do y value 1 minus y value 2, or you can say y1 minus, well, usually we format it as y2 minus y1, but 4 minus 1, and then divided by 3 minus 2. So 4 minus 1 divided by 3 minus 2, and that gives you 3 over 1. So the slope of this line is 3. Okay, a while back, we reviewed just some general characteristics, remember, about slope. And we said that a slope is positive if it slants up and to the right, and that it's negative if it slants down and to the right. Well, notice we just calculated slope, and it was a positive 3. And this line does. It slopes up and to the right. So we're on the right track. Okay, for example B, use -2, comma, and they expect you to go to the graph and find it. It's -2, comma 3 as your first point, and then subtract your y values to find the change in y, or rise, and then subtract the x values to find the change in x, or run. Okay, so I decided that this ordered pair was my first point and that this other ordered pair was my second point. It doesn't matter which one's the first point and the second point, as long as you don't like mismatch stuff. Okay, so y2 minus y1 divided by x2 minus x1. Be careful here. Minus a negative really means you're adding that 2. So 1 minus a -2 gives you 3. And -3 divided by 3 is a -1. So it says the slope is -1, and if you look, the line does slant down and to the right, so it should have a negative slope. Okay? All right, and here is just what I mentioned a second ago. It doesn't matter which pair I decide is my second point and which ones I decide is my first point, as long as you're consistent. You can't, for instance, do y2 minus y1 and then x1 minus x2, because then things are not going to work out for you. Okay, so as long as you're consistent, second value minus first value, second value minus first value, or first value minus second value divided by first value minus second value. Okay? All right. Number 4, on the reflection, it says find the rise of a horizontal line. What's the slope of a horizontal line? Okay. Okay, and this little thing I'm pointing out is my little thing just saying, remember, don't mix and match. That's not actually part of number 4. Okay, so the slope of a horizontal line is 0 because there is no change in your y values. Okay, like if you have a horizontal line, your y value would be like 3, and then your other y value is still 3 because it's a horizontal line, so you wind up with 0 on top. Okay, find the run of a vertical line. Okay, what is the slope of a vertical line? I didn't really answer that. The slope of a vertical line is undefined. You need to memorize these. A horizontal line has 0 slope. A vertical line has an undefined slope. Okay? If it slopes up and to the right, it's a slope that's positive. If it slopes down and to the right, it is a negative slope. Okay? So positive slope, negative slope, horizontal is 0 or no slope. Vertical is an undefined slope.